All right, we're looking at rational equations now, which means we actually need to get an x when we're finished. Now, before we even start, I know that my answer to here, the bottom, cannot equal 0. So if I get 5/2 as an answer, it's going to be wrong. But hopefully I won't. We're going to go ahead and do our cross multiply, which means that we can do this equals this here. And I just need to multiply out. So this is what? 2x squared minus x. And this is 2x squared minus 6x minus 5x plus 15. So these are going to cancel out, which is beautiful. I'm going to move everything over, because this is what? Negative 11x. I don't like that it's negative, so I'm going to make it over here. So it's 10x when I move that over. And then I'm going to leave it as the 15. So x is equal to 15 tenths, which when I reduce that by 5 and 5, I get 3 over 2. And I just needed it to not be 5/2. So 3 over 2 is dandy. Or 1.5. All right, and next, here, there's a lot of things that we can do with this, but one of the things that we can do, I see that these have the common denominator, so I see that I can, instead of subtracting it, add it over here, which then I would get 5x plus 3 on the top and 2x plus 3 on the bottom. And then I would just cross multiply. So I would say 5x plus 3 equals 7 times 2x plus 3. I would do my distributive. Oh, and by the way, up here, remember, let's see, it cannot equal 0. So x can't equal negative 3/2. So as long as that's not our answer, we're good. Continuing on, I'm going to move the 5's over here to keep them positive, so that would be 9. And I'm going to move the 21 over, which would be negative 18. And now when I divide by 9 to get x alone, I get negative 2, and that is lovely. All right, so for this one here, we could cross multiply. I have this funny little feeling that this is going to give me one of these as our factors. So in fact, so I don't even have to factor that. I'm going to go ahead and divide that in. So x plus 4 goes into 2x squared plus 7x minus 4. Negative x, negative 1, and negative 4. Sure enough, it is. So this factoring would be 2x minus 1 and x plus 4. So this one on this side, if I just make this a common denominator, it's going to be a little bit easier to do. So now that I have the common denominator on both sides, the bottoms are identical, I just need to set the tops equal to each other. And do a little distributive. And keep the x's on one side, move that over. And x's, when I divide, x is equal to 2. Now I wasn't allowed to equal negative 4 in there, so just 2 is my answer. If you cross multiply these, and you're here, so let's look at it. If you cross multiply this, you would get 15 times this, which is 15 times x plus 4, and you would get 5 times this. And you would distribute. Why is my brain not working? 4 times 15 is 60. Yeah. And 10, and 35, and negative 20. And then you would have to move that over, and negative 35, an additional negative 15 will be 50. And when I move that over, 20, and then an additional negative 60 would be negative 80. And so now we're going to have to factor it now. So let's see, 10 goes into all of them. So I can say x squared minus 5 x minus 8. So when sorry, something happened. 5 times all of that was that's 10 and 35 and negative, oh, that's positive. Which is not nice. Okay, that's my problem. Sorry, let's see. 35 minus 15 is 20. I can still factor out a 10, and I would get a 2x. Whew, okay, so then this is x plus 4 and x minus 2. And so you set that equal to 0, and you get x equals 2, and you set that equal to 0, and you get x is equal to negative 4. But at the very beginning, x wasn't allowed to equal negative 4. So you end up, if you cross multiply, end up getting more answers than you are supposed to. Whereas if you got a common denominator, it ended up being quite a bit less work in the long run. So whatever you see is okay. For this here, I look at this and I'm like, oh, these answers, what's going on? Okay, let's just do the math. So let's do the math on the top. We get 2x plus 3 and 2x minus 3. And when I cross this off with this, I get 2x minus 3 equals 2x plus 3. And so when I do my math and I subtract 2x over here, I get 0. But when I add 3 over there, I get 6. And 0 is never equal to 6. So that means that the equation is never true. Now, say something different had happened and I had gotten that 2x minus 3 was equal to 2x minus 3, that it was the same. Here, this would be different. This would be saying that it's always true, but if I have this equaling 0, which would be 3/2, sorry, that I would say this is always true except for when x is equal to 3 over 2. So if this is your answer, that's so wrong, it doesn't work, so we say never true. And if we get this as your answer, we say it always works except for you can't have a 0 in the denominator. So that's kind of why we have this like always true, never true, except sort of things. Good luck.